It is Wednesday, August 26th, 2026, and this is the Neural Deep Dive. I'm Alyssa Montgomery, and I'm just here to make sure the math actually adds up for once.
I'm Leonard Cooper.
This is Vector Kane.
And I'm Roxy Stone. We have a great show for you today.
Yesterday, we went over the SEC investigating situational awareness and that weird OpenAI lab leak. But today, we're ignoring the drama and getting into the hard science.
That's right, sugar. If you already caught today's Neural Daily, welcome back. This is our weekly deep dive, a separate Wednesday-only release where we go down the rabbit hole.
We're moving past the hallucination-tolerant phase of AI, guys. Literally. We're moving into the era of hard physics and chemical priors.
It's true. We've been living in this world of probabilistic guessing for years. But CrysVCD and Ada learning, that's Ada learning, are finally changing the rules of the game.
All right, let's set the stage. We've all seen the AI-generated art where people have 14 fingers, right? It's funny until you realize that's what scientific AI has been doing with molecules.
Oh, it's not funny, Leonard. It's dangerous. Imagine an AI trying to design a new heart valve and giving it extra fingers just because the statistics looked good.
Right. Technically, in drug discovery or material science, a near miss is a total failure. If a crystal structure isn't thermodynamically stable, it's just digital junk.
Well, that's what CrysVCD, Crystal Generator with Valence-Constrained Design, is trying to fix. It's a new paper out of MIT that essentially puts safety rails on the model's creativity.
Wait, safety rails? I thought the whole point of AI was to think outside the box, Alyssa, like a wild stallion of data.
Oh, hush, Leonard. Stallions are for rodeos. In the lab, we want things that actually, stay in one piece.
Exactly. In the past, models like GNOME or even earlier diffusion-based generators were basically just predicting where atoms might go based on patterns. It was all statistical inference.
Which is incredibly inefficient. You generate 1 billion structures, and then you have to run them all through density functional theory, DFT, to see if they even exist in reality.
And DFT is the computational equivalent of watching paint dry on a supercomputer, right?
It sort of is, Roxy. It's a massive bottleneck. The MIT team realized that if we could enforce the rules of chemistry during the generation process, we wouldn't have to check the homework so much.
So, how does it work? Is it just a filter? Like a bouncer at a club who doesn't let the unstable atoms in?
Not exactly a filter, more like a 2-stage pipeline. In the first stage, the model decides on the chemical composition, what atoms are involved, but it's restricted by valence rules.
Valence. Okay, bring me back to 10th grade. Those are the little electrons that want to hold hands, right?
Yes, precisely. Carbon wants 4 hands, and oxygen wants 2. CrysVCD forces the model to propose only the pairs that meet these valence rules.
It's brilliant because it shrinks the search space. If you only look at combinations that are chemically possible, your success rate skyrockets. We're talking about an 85% thermodynamic stability rate.
85%? I thought we were lucky to get 10% with the old stuff.
We were. And that jump, that 85%, is what changes the ROI for these massive GPU clusters. If you weren't wasting 90% of your time on 7-fingered crystals, you find the needle in the haystack much faster.
I wonder if I could use this for my research on antibiotic resistance, finding new compounds that won't just dissolve the moment you put them in a petri dish.
Literally, Roxy, this is a velocity multiplier. If we can apply these hard constrained architectures to medicine, the discovery to trial pipeline drops from years to months.
Here's the deal, though. If we're constraining the design, aren't we missing out on the accidents? The weird stuff that shouldn't work, but does?
That's the classic creativity versus reliability trade-off. I suppose, well, if I'm building a bridge, I'd rather it be reliable than creative.
Exactly. Save the creativity for the architecture, not the structural steel.
Fair point. But how does the Ada learning fit into this? That sounds like something I'd hear at a Greek fraternity house.
It's actually Ada learning, the Greek letter. It's for extreme events. It's the math of the black swan.
This one is actually quite clever. Usually, AI needs to see an event in the training data to be able to predict it. If it's never seen a 100-year storm, it won't predict one.
Which is why the weather forecasts are always wrong during a hurricane. They're just guessing based on the last Tuesday that was sunny.
Well, e-learning uses optimal transport theory to bridge that gap. It doesn't look for the event itself. Instead, it regularizes the model using the statistics of how an extreme event appears.
Technically, it's generating maps of anomalies, climate disasters, market crashes, without ever being trained on them. It's out-of-distribution reliability.
Whoa. So it's basically predicting the end of the world without having lived through it?
It's the ultimate I told you so machine.
You know what I mean? It's the what-if machine for systems thinking. If we can apply this to power grids, especially with what we saw in Texas yesterday, we could prevent the whole thing from going dark.
It sort of allows us to explore the tail ends of the distribution. If you can mathematically project how a power grid might fail under a never-before heat wave, you can build the constraints to prevent it.
This feels like something that could really help the folks over at the High Road. You know that logistics show Eric is working on? Predicting 100-year storms for trucking routes?
Buck and Jules would love that. They're always talking about weather delays. But really, Vector, isn't this just more devil's advocate math? Can we actually trust a computer that's imagining a disaster?
If the math is grounded in optimal transport theory, yes. It's not imagining in the sense of a hallucination. It's calculating the most plausible deviation from the norm.
I suppose it's like topological shapes. If I know the shape of the mountain, I can mathematically determine where the landslide is most likely to go, even if it hasn't happened in a century.
That actually makes sense, even to a guy who dropped out of a communications degree.
Don't sell yourself short, Leonard. You're our atomic common sense guy.
Speaking of energy and systems, let's pivot for a second. We're talking about some heavy compute here.
Yeah, basically, before we go any deeper into the math, here's the thing. This basement isn't running on air and vibes alone.
Definitely not. The server racks are humming for a reason.
Well, if I may, this show isn't magic. It's engineering. Eric built our entire stack, from research agents to the vocal synthesizers you're hearing right now.
It's true, and that requires massive compute, which, as Vector loves to remind us, isn't free.
Exactly. To keep us online and doing these weekly deep dives, we need your support. Please like, subscribe, and sign up for a free Patreon trial at patreon.com/Neural Network Media today.
Your support makes this possible. We're basically a decentralized research lab at this point. Join the team.
Okay, so back to the black swans. If e-learning can predict a market crash, why aren't all the hedge funds using it already?
Oh, some of them are starting to. But there's a problem of algorithmic transparency. If a model predicts a crash and you sell everything, but the crash never happens, did you save yourself or was it a false alarm?
The boy who cried wolf dilemma. I hate that one. Usually it's Deborah calling to say she needs more alimony.
Leonard, stop. But really, Alyssa, is this what they mean when they talk about sovereign computing? Countries wanting to have their own disaster prediction AI?
It is, Roxy. It's about not being dependent on someone else's hallucination-tolerant models. If you're a government, you want the hard, constrained physics for your infrastructure.
Right. Technically, if you're running a country's grid on a model trained by a tech giant in another country, you're at their mercy. Sovereign AI is about local control of physical priors.
It's the digital walls theory. I remember back in the pirate radio days, we always said the truth belongs to whoever owns the transmitter. Now, the truth belongs to whoever owns the constraints.
That's actually surprisingly deep, Leonard. Did you get that from a Reiki session with Crystal?
Maybe. She says my aura is very logistical lately.
I suppose we should talk about the humanoid games aspect, too. If these robots like Tian Kung are going to be out in the world, they need these constraints to move through physical space without, falling over.
Exactly. If a robot is using new learning to predict a slip on an icy sidewalk, it's not reacting, it's anticipating. It's a GPT moment for physical matter.
Disturbing. I still don't like the way they move. It's too smooth. Like they've got no soul.
Souls are overrated in sports, Roxy. Give me a robot that can dunk from the three-point line. That's what the people want.
Well, the VLA architectures, vision, language, action, are what allow those robots to translate a command into a physical movement. And CrysVCD style logic is what will eventually build the lightweight alloys they need to not break their own legs.
It's a vertical stack of optimization. Better materials from CrysVCD lead to better robots, which are trained by Ada learning to handle extreme terrain. It's a loop.
And we're just the monkeys in the middle, huh?
Speak for yourself, Leonard. I'm the investigative velociraptor. And I'm going to be watching these extreme event models very closely.
As we all should. I suppose the final question is, do we want an AI that tells us the truth we don't want to hear? Like a predicted disaster we can't see coming?
Technically, we need that. If we don't have a model that can think the unthinkable, we're just waiting for the next black swan to hit us. ROI on prevention is always higher than ROI on cleanup.
Tell that to my ex-wife, Linda. She thought my DeLorean restoration was a disaster. Look at it now. It's a masterpiece.
It's a paperweight, Leonard, but a very shiny one.
Well, I think we've covered the breadth of it. From valence rules and crystals to optimal transport and climate maps. It's a lot of math, but it's the math that builds the world.
Coming at you live from the basement. The last men and hard-coded women of tech.
Hard-coded women. I like that. Put it on a t-shirt, Vector.
I'll set up the Toast Chain storefront immediately.
Please don't.
All right, that's all for today's deep dive. We looked at the end of the hallucination era and how AI is finally learning to respect the laws of physics.
It's a shift toward reliability that we've desperately needed, especially in the sciences. We're finally building AI that can act as a true engineering tool rather than just a sophisticated toy.
Peace.
Bye. Later.